Dr. Thabane received his PhD in statistics from Western University, and he has extensive knowledge of clinical trials, evidence-based medicine, research ethics, systematic reviews, and conjoint analysis of patient preferences for health services. With that being said, we hope you enjoy our conversation with Dr. Thabane on statistics and its real-world implications.
Hello, everyone. We are with Dr. Thabane again. We're going to be talking about the importance of looking at clinical relevance and not just only the statistical significance in our medical literature and scientific literature.
There's a reason, whether it's logical or not, it's a different issue. And the reason being, we have adopted as a convention in science to use thresholds for p-values to decide whether a finding is statistically significant or not. And this has a history way back when R.A. Fisher, who actually suggested this approach, was doing his science himself. Although really Fisher, although he encouraged people they could consider using this as a rule, he never really encouraged using it as an absolute rule. You know, he did mention the whole spectrum between 0 and 1, where the p-value lies in terms of how you could use different areas of that spectrum to decide how to interpret what the p-value is telling you about the strength of the evidence. But unfortunately, because he had also encouraged using the level of 0.05 as a convention, that's what everybody now uses blindly as a convention to decide whether something is significant or not significant. But when you think about it, a p-value of 0.49 or 0.49 and 0.051, they're essentially not that different, right? This is where you see the absurdity of relying on this threshold, because numerically and in fact, in terms of messaging, those two results may not be different at all. So, which is why the goal has really been how to educate people to actually put less emphasis on p-values, but rather more on other aspects of the evidence that are much more informative than a p-value is. The obvious challenge is as soon as something meets that threshold, guess what? Everybody jumps on it. The scientists themselves, their institutions, the press, the journal editors. We have had papers get rejected by journals despite providing very good, useful information, simply because they have a result that falls below that threshold. Above that threshold, if their p-value is above 0.05. But if it's less than, it gets attention and the paper gets accepted. And this has led to what we call publication bias in science. We've also had a situation where the prevalence of studies that have reportings of p-values less than this threshold, they're actually much higher than you would expect. I think one of our colleagues, John Ioannidis, actually found that over 90% of studies that have p-values less than this, that's what you will see in their abstracts in the literature. And that's high overrepresentation of what happens. We all know that for every success, there has been lots of failures. There has to have been many, many others that have p-values above that threshold that certainly would not have been accepted for the ones that have it lower being so prevalent in the literature. The third thing is quite often when these things are overrepresented in abstracts and so on, which may actually be a representation of false positive findings, that's what the press picks up on. So if you're going to find anything that gets media attention, more likely than not, it will be something that is has a p-value less than 0.05 and therefore is statistically significant. It's very unlikely that a study that is not statistically significant will get media attention. So you can see that there's lots of potential unintended consequences of us paying attention to things that may not necessarily serve us well as a society, but they tend to have what people perceive as a good finding because they're statistically significant. More common than perhaps we would want to see it happen. There was a study a few years ago that actually looked at the very same issue in trials of heart disease. In other words, studies that are looking at interventions to deal with heart conditions. So we call those clinical trials, controlled clinical trials in cardiovascular trials, right? So what they found was that over 61% of studies that were published dealing with cardiovascular trials, they actually had a result that was first not statistically significant. And however, they had a confidence interval of the clinical effect estimate, including an area or the lower confidence interval of that, including an area of clinical relevance. Right? So if 61% of studies that are not statistically significant are found to be clinically useful in cardiovascular trials, you bet it is not the only area where this happens, right? So, and now you can imagine, these are the ones that were published. Now, imagine how many more that were not published because they were rejected for not showing statistical significance out there. So obviously, this is an issue that's much, much more prevalent than perhaps we would want it to be. And I'm sure cardiovascular trials is not the only area where this happens. Rather than just encouraging to be looking for certain numbers or certain statistics in a study, or rather we encourage them to use a much more global approach to it, right? First, people need to be educated about methods issues in research. People need to be educated about epidemiological issues in research. I'm using the word epidemiological issues because we're talking about this in the context of health studies, right? So epidemiological issues, methods, and certainly the importance of understanding how we design studies and how we conduct studies, how we report them, and reporting guidelines are essential as part of this, and certainly how we interpret these things. And you'll notice that, you know, if people are equipped with all those skills, they are more likely, therefore, to oppose the design of studies, the conduct of studies, the analysis of studies, and interpretation of studies in a much more balanced approach, right? So, you know, p-values are just one aspect of outputs that come out of analysis of any study. They do have a role to play, but certainly it is not the most useful, nor is it the most important aspect of the findings from a study. Quite often we do studies because we're trying to get a sense of whether something does more good than harm, if so, by how much. Therefore, the magnitude of effects, whether it's harmful effects or beneficial effects, it's absolutely essential. The p-value can't tell you that. Only confidence interval can tell you about a sense of the magnitude of effects. And therefore, reporting magnitude of effects is absolutely essential. It's equally important, actually, for people to report the methods used to get there, right? There's good methods and bad methods, just like everything else. The results, and whether it's confidence interval or anything, they're only as good as the methods that are used to get there. So it is equally important for people to understand all those things, because It is, when we come to science, it is not really an issue of what is the result. It is the issue of the credibility and the integrity of that result. So, and we can't assess that unless we understand the methods and we're educated about the potential when you're executing it, including when you're reporting it and interpreting. All those biases, we need to be aware of them, and we need to be aware of the strategies to mitigate them. We can't totally eliminate bias in life, which is a systematic deviation from the truth, but we can make efforts to minimize them. And therefore, everything really should be geared towards minimizing all these errors throughout the spectrum of actually how we do research. So I wouldn't say focusing on reporting is perhaps the best strategy. We need to start focusing from education before we even do the studies in the first place.
I think that's really interesting. And one of the things that I think it's really common when we open a paper, we just skip to the results section and look for that p-value, and we're like, that result is significant. I'm going to start applying this. And you made a really good point that it should be a holistic view of the whole research that was conducted. What was the method? What was the other values? And also, I think confidence intervals, you're absolutely right. They show the magnitude of the change instead of just whether this change was statistically significant or not. So I think that's highly relevant as well.
Yes, we need to intensify our efforts in training. But I'm going to say something that I know I'm not the first person to say this. There's many other people who have said the same thing, that part of the challenge is the entire academic culture. The way institutions reward efforts in research is problematic. How people are hired, how people are promoted, how people are celebrated, in some ways contributes to this problem of people putting more emphasis on things that are really not that serving us that well, like statistical significance and so on. So I think academic cultures really need to change in how we actually approach rewards and incentives towards doing good research and reporting good research and doing it well. So that's the first thing. The dream that I don't know whether it'll ever happen, but it's necessary. Second thing is, you know, the editors, right? It's not enough to actually change the academic culture. We need to change the whole culture of editorial policies and peer review systems that actually look at this work and decide whether it merits publishing or not publishing. You know, if we could be in situations where all editors could commit to first encouraging people to report things well, and perhaps encourage people not to put so much emphasis on p-values and so on, that would also help. And of course, we need to educate peer reviewers who are really part of the system to be able to do that. By peer reviewers, I mean everybody, essentially, because every author is a potential reviewer for any journal, right? So, and we need to get all these things really into graduate education or in education for our students. We can't change a culture unless we change how we actually approach education for everybody. So all these things are absolutely essential in being able to actually do some change that will achieve something. But we also have public funders who support research that's been done. I think if they placed conditions upon which the research that they support, how it should be reported, and so on, that could also happen. We know that money gets people to change behavior. So if perhaps part of the approach would be such, funders will require that, okay, you've done the study, we will have our own panel that will look at how you report it, to make sure that you report all the things that would be informative to society that has contributed to this effort. but we leave it to the authors themselves. We also leave it to the editors, many of which are not educated about what to look for and how to look for it and so on. So it is, but it all stems from the willingness to educate everybody.
It's definitely a multifaceted approach to be able to make some improvements in this field for sure. Dr. Thabane, it was a pleasure to have you. Hopefully we can change the mind of some clinicians, some graduate students to have a more holistic approach in reviewing literature and understanding research papers. Again, thank you for having this interview with us. We appreciate it.